Welcome to my channel. In this video, we are going to discuss about the multiple choice question and answer from the fourth unit, that is the analysis of discrete time signals. So in the previous videos, we discussed the first unit, second unit and the third unit. So from the three units, the multiple choice questions and answer we discussed. Okay, so now we are going to see that is the questions from the topic sampling process. Okay, so first, what is mean by sampling. The sampling, it is nothing but it's a process of converting the continuous time signal into discrete signal. Okay, the x of t we must convert into x of n, that is called as a sampling process. So in this sampling process, there are so many technical terms are there. Shannon sampling theorem, Nyquist rate, Nyquist interval, and with respect to that one, there are so many two more problem is also there, important problem is also that. Okay, so we are going to discuss about this thing. So if you want to learn more about this sampling process, so already I posted that video. So in the fourth unit, that 4.1. So I will give link for those videos in the description box. You can verify it. Okay. So the first one. So here in the question and answer format, we are going to see. So the first question, you see the process of converting continuous time signal into discrete time signal is called as dash. Okay. So the process of converting the continuous time signal means x of t. Discrete time signal means x of n. So in order to convert the x of t to x of n, what is the process we are using? One, you see quantization, sampling, encoding, decoding. Okay, the sampling, it is a correct answer. Sampling is nothing but it's a process of converting the continuous time signal x of t to x of n. Okay, the next one, the time interval between two subsequent sampling instant is called as, that is so in this is one continuous time signal. So in that signal, we are taking the first one, first sample we are taking here, the next sample we are taking here. So the distance between, okay, the time interval between these two subsequent samples is called as dash. It's a sampling interval, sampling frequency, data rate, Nyquist rate, sampling interval. So the time interval between two successive sample is called as sampling interval. Okay. The next one, the sampling theorem was introduced in the communication theory by Dash. Okay. So the sampling theorem was introduced by the Shannon. Okay. So here the four answers given: Shannon, Miller, Hartley, Millman. Okay. The Shannon only introduced the sampling theorem in order to perform the sampling process in a perfect way. So this is the Shannon's, that's why the sampling theorem is called as Shannon sampling theorem. Okay, this is the one. And the next one, which one is the Nyquist rate? So what is mean by Nyquist rate means, so if we want to perform this sampling process, so that is, this is, you just consider this is one cycle. So in order to recover, that is in transmitter side, we are converting this continuous time signal into discrete signal and we are processing and we are transmitting. Okay, so in receiver side, we are receiving this discrete time signal and again in a thing we have to convert this discrete signals into once again the continuous time signal. So in order to recover this signal exactly in the receiver side, so we have to take so many samples as possible. Okay, so as maximum, if you are taking many samples in that one cycle means at the time only we will recover the signal in the receiver side in a perfect manner. Okay, so so how many samples? So in minimum, how many sample we have to take at least in a one cycle? It is defined by the Shannon sampling theorem. So that is called as a Nyquist rate. Okay, so in order to take a minimum number of samples in a particular one cycle, so the Nyquist rate. So which Nyquist rate is nothing but the minimum interval. Okay, so the minimum interval at which the frequency can be taken. Okay, so which one is the sampling rate means fs equal to 2 fm, fs greater than 2 fm, fs less than 2 fm, fs is equal to 4 fm. So fs is equal to 2 fm, that is in order to satisfy the Shannon sampling theorem, the condition is that Fs means the sampling frequency. The sampling frequency Fs, it must be greater than or equal to 2 into Fm. This is the condition for sampling process. So the minimum sampling frequency. So which in this condition, which one is the minimum sampling frequency? Fs is equal to 2 Fm. So Fs equal to 2 Fm, the minimum sampling frequency or sampling rate is called as Nyquist rate. Okay, so Fs is equal to 2 Fm is nothing but a Nyquist rate. Okay, so this is the condition. You just remember which one is the Nyquist interval. So the Nyquist interval is nothing but the reciprocal of Nyquist rate. Okay, so what is the Nyquist rate formula? The Nyquist rate is Fs is equal to 2 Fm. Okay, so the reciprocal of this Nyquist rate, it is called as a Nyquist interval. So the Nyquist interval is equal to 1 divided by 2 Fm. Okay, since the Nyquist rate formula is Fs equal to 2 Fm. So the reciprocal of 1 by Fs. 1 by Fs is Ts, Nyquist interval. So the answer is 1 divided by 2 Fm. Okay, so 1 divided by the 2 Fm, it is called as a Nyquist interval. So here you see A is the answer. 1 divided by 2 Fm is the Nyquist interval. Then the next one, Nyquist interval is the reciprocal of Nyquist rate. Okay, it's a correct or true or false. Yes, Nyquist interval is nothing but a reciprocal of the Nyquist rate. Okay, true, so true only. Then the next question, dash is the minimum sampling rate. Okay, dash is the minimum sampling rate at which the signal can be converted into samples and can be recovered back without distortion. So sampling interval, conversion rate, data rate, Nyquist sampling rate, Nyquist sampling rate. So the Nyquist sampling rate, it is nothing but what is Nyquist sampling rate? Fs is equal to 2 Fm. Okay, so you see this question, the Nyquist rate or Nyquist sampling rate. Fs is equal to 2 Fm. So this is the minimum sampling rate. Okay, this is the minimum sampling rate at which the signal can be converted into samples and can be recovered back without distortion in the receiver side. Okay, so this is the answer. And the next one, which one is correct according to Shannon sampling theorem? Okay, so according to Shannon sampling theorem, the sampling frequency Fs, we have to select either less than 2 Fm, greater than or equal to 2 Fm, less than Fm, greater than or equal to Fm. So which one is correct means the sampling frequency Fs, it must be greater than or equal to twice the maximum frequency of message signal. So this is the correct answer. So this is the very important condition in the sampling process. Okay, Shannon sampling theorem. In order to take samples in the continuous time signal, we have to follow this condition. The sampling frequency Fs is nothing but sampling frequency. Fm is nothing but the maximum frequency of the message signal. Okay, then the next one, a filter that is used to reject the high frequency signal before it is sampled to reduce the aliasing is called dash. Okay, so if in the sampling process, if we are not at all taking the sampling frequency Fs greater than or equal to 2 Fm, that is, for example, we are taking Fs as less than 2 Fm means, so at that condition, so we will get one error or distortion in the received signal. So that distortion, it is called as a aliasing process. Okay, so aliasing process. So what is meant by aliasing means? So in the next question we will see. So in order to reduce this aliasing, we are using that, you see, a filter that is used to reject the high frequency signal before it is sampled. So before performing the sampling process, that signal x of t is passed via one filter in order to avoid the aliasing. So that filter is called as anti-aliasing filter, aliasing filter, band pass filter, band stop filter. It is an anti-aliasing filter. So this anti-aliasing filter, it is nothing but a one low pass filter. Why the name is anti-aliasing means this anti-aliasing filter is used to reduce the distortion, aliasing distortion. So that's why the name is called as anti-aliasing filter. Okay, so this is the answer. Then the next one, which of the following is the process of aliasing? So aliasing means the overlapping of the spectrum. Okay, so you see the overlapping of the spectrum, the higher frequency component of one thing is overlapped with, that is, this is the spectrum if we are choosing the sampling frequency fs is greater than or equal to 2 fm. Okay, that is in that video, that full thing we explained in a very detailed manner. Okay, so if you want to study that is more about the sampling process means you go on 4.1. Okay, in signals and system playlist, the 4.1 sampling process, you go and study. Okay, so you see these are all the that is the spectrum obtained for different sampling frequencies. Okay, the first one you see, so if fs is greater than 2 fm means we will get the spectrum like this. So in this case there is no overlapping. Okay, if fs is equal to 2 fm means in this case also no overlapping. But you see if you are selecting the sampling frequency fs is less than 2 fm, so you see here we are getting the overlapping. Okay, that is the higher frequency component of the first spectrum is overlapped with the lower frequency component of the adjacent spectrum. So that's why here some information, that is two spectrums are gets overlapped. So due to this overlapping in this that is the data in this frequency is lost. Okay, so that's why this process is called as a aliasing process. So aliasing, it will occur in which condition? If you are selecting the sampling frequency fs, it should be less than 2 fm. Okay, so if we are not at all satisfying the condition fs greater than or equal to 2 fm, at the time we will get the aliasing. So which of the following is the process of aliasing? Peak overlapping, phase overlapping, amplitude overlapping, spectral overlapping, Okay, so that is you see the definition. Aliasing, it's defined as a phenomenon in which the high frequency component in the frequency spectrum takes the identity of the lower frequency component in the spectrum of sampled signal. So this is called as a aliasing. So in order to that is the aliasing, in which condition the aliasing can occur means in two things. One is the signal is not a band limited signal in a finite range and the sampling rate is too low. That is fs, we are selecting very less than 2 fm, or the signal is not a band limited signal. In that two condition, we are getting the thing, it is called as the aliasing. So the next one, how to eliminate aliasing. So in order to reduce the aliasing process, so we may use, so one is the anti-aliasing filter. So what is meant by anti-aliasing filter? That is we have to pass before performing the sampling process. So you see the x of t signal, x of t, this is the continuous time signal. This is the sampled signal. So the sampler, it is performing the process sampling. So before performing the sampling process, the x of t signal must pass via one filter. So this is one low pass, anti-aliasing low pass filter. Low pass filter in order to reject the high frequency components. Okay, so this filter is called as the anti-aliasing filter. So a filter that is used to reject the high frequency signal before it is sampled to reduce the aliasing, it is called as the anti-aliasing filter. This is the one thing. Okay, then the second one, in order to reduce the aliasing, we have to select the sampling rate. The sampling rate fs is very greater than 2W or 2FM, where W or FM is the maximum frequency of the message signal. So these are all the two things in order to avoid the aliasing process. So here the four condition is given. One is use anti-aliasing filter before performing the sampling process. Yes, it is correct. Increase the sampling frequency fs to extend fs very greater than 2W, where W is the bandwidth of the message signal. Okay, the maximum frequency content of the message signal. The third one, decrease the sampling frequency. No. Okay, both A and B. Both A and B is the answer. We have to use anti-aliasing filter. Another one, we have to use the sampling frequency. It should be very greater than 2W. Okay, so these are all the two things in order to eliminate the aliasing process. Okay, the next question, the aliasing will occur when, so in which condition aliasing will occur? If you are selecting the fs less than 2 fm, fs greater than 2 fm, fs very greater than 2 fm, fs equal to 2 fm. So fs less than 2 fm. Okay, in that condition only the aliasing will occur. Fs equal greater than, very greater than, equal to 2 fm, the aliasing will not occur. Whenever the sampling frequency is selected less than 2 fm, at that condition only we will get the aliasing. Okay. Next one. So we have to see about the problems related with this sampling process. Okay. So here you see the sampling frequency of the signal Fs equal to 2000 samples per second. Find its Nyquist interval. Okay, so the Nyquist interval, what is meant by the Nyquist interval? The Nyquist interval is nothing but the reciprocal of this sampling frequency. Okay, so the reciprocal of the sampling frequency, it is called as a Nyquist interval. So the Nyquist interval T equal to 1 divided by Fs. So 1 divided by the 2000, it's a 0.5 millisecond, 0.5 into 10 to the power minus 3. So that's why 0.5 millisecond. Okay, so this is the one of the question. Then next one, find the Nyquist rate and the Nyquist interval of sine 2 pi of t. So here the sine 2 pi of t is our sine 2 pi t is our continuous signal x of t. Okay, so find the Nyquist rate and the Nyquist interval. So what is Nyquist rate? The Nyquist rate Fs equal to 2 into Fm. This is the formula. So in order to find the Nyquist rate, we have to calculate Fm. What is mean by Fm? Fm is nothing but the frequency, the maximum frequency of the message signal. So this is our message signal sine 2 pi t. So we have to find the frequency of this sine signal. Okay. So already you know we have to compare this sine signal with the standard sinusoidal expression. What is the standard sinusoidal expression? A sine 2 pi ft. So if you are comparing that thing, the 2 pi f is equal to 2 pi. That is omega. In the place of that is sine omega t, sine omega mt or sine 2 pi ft. So in the place of omega m, what is the thing is there? 2 pi. So what is omega? Omega, if you are expanding, it is a 2 pi fm. So comparing these two, so 2 pi equal to 2 pi fm. So 2 pi cancel. So fm is equal to 1 hertz. Okay. So therefore the Nyquist rate is equal to 2 into fm. So 2 into 1, 2 hertz. And what is the Nyquist interval? The reciprocal of Nyquist rate. It is called as a Nyquist interval. So the Nyquist interval is equal to 1 divided by this Fs. So 1 divided by 2 seconds. Okay. So the unit for Nyquist rate is hertz. Since Nyquist rate is a frequency, Nyquist interval is a time. Okay, it's a seconds. So the answer is 2, 1 by 2. So 2, 1 by 2. So 2 hertz, 1 by 2 seconds. This is the answer. Okay. And next question. So similar to the previous question. So here some different data is given. Find the Nyquist rate and the Nyquist interval for the signal f of t equal to sine 500 pi t. Okay. So here the different frequency component is given. In the previous problem, sine 2 pi t. Here sine 500 pi t. Okay. So anyway, you just compare the given signal with the standard sinusoidal expression. So according to that, the omega m, okay, the radian frequency omega m is equal to this 500 pi. So omega m, it can be expanded as 2 pi up. So here the pi cancel. Then if you are calculating the FM, we will get 500 divided by 2. It's a 250 hertz. So the frequency of our given message signal is 250 hertz. Okay, so therefore the Nyquist rate is, what is the formula for the Nyquist rate? The Nyquist rate is nothing but the minimum sampling rate. It is called as Nyquist rate. So Fs is equal to 2 into Fm. So 2 into 250, it's a 500 hertz. Okay. Then the Nyquist interval is 1 divided by this Fs value. So 1 by 500. If you are calculating, we will get the answer 2 millisecond. So the answer is 500 hertz, 2 millisecond. So B is the answer. Okay. So similarly, instead of sine, there may be cosine signal given also. You just compare it with the standard cosine waveform. You just calculate the frequency and you twice the frequency means that is nothing but the Nyquist rate. Okay, so then you see the next question. Determine the Nyquist rate of the signal x of t equal to 1 plus cos 2000 phi t plus sine 4000 pi t. So in the previous two problem, the signal consisting of only one waveform. But here the x of t, it's a composite signal. It consists of the addition of the three signal. One is the constant one. What does mean by the constant one? It's a DC signal. Okay. Then the next one is cos 2000 pi t. It's a one cosine waveform of some frequency. Another one is sine waveform of some different frequency. Okay, so in order to find out the Nyquist rate, so you know the Nyquist rate is nothing but Fs is equal to 2Fm, where what is Fm? If the given signal is a single signal, the frequency of that single signal is the Fm. Okay, if the given signal x of t, it consisting of the different mixing of different frequency component, means we have to find out the maximum frequency of these three signals. Okay, that is the Fm. Fm is the maximum frequency component of the given signal. Okay, so that's why first you note down, first you see 1 is nothing but DC signal. So for DC signal, the frequency component is 0. Okay, so next we have to find out the frequency of this cosine signal. So the frequency component in cosine, cos 2000 pi t is, that is, you just compare this cosine waveform cos signal with the standard cosine expression. So omega m1, the radian frequency, omega m1 equal to 2000 pi. What is omega? 2 pi f1. Okay, so if you are comparing this, we will get the frequency of this signal. Okay, this component is 1000 hertz. Similarly, you just compare the third thing, sine 4000 pi t. So the frequency component of sine 4000 pi t is, you just compare it with the standard sine signal. So omega m2 equal to 4000 pi. So f2 equal to 2000 hertz. Okay, so we calculated the first component frequency is 0. For the second component frequency is 1000. For the third component, the frequency is 2000. So out of this three things, which one is highest, we have to calculate. Okay, so 0, 1000, 2000. In this, which one is the highest frequency? 2000 hertz. Okay, so that 2000 hertz is nothing but a FM. FM means maximum frequency component of the given signal. Okay, so therefore, the Nyquist rate is equal to twice the FM. So 2 into 2000, it is 4000 hertz. Okay, so here the answer is 4000 hertz. So in this manner, we have to work out the problem if the signal consisting of 2 or more different frequency signals. Okay, then the next one, the Nyquist frequency of the signal. So here the 3 signal is given. Okay, 2 signal is in addition, 1 thing is in subtraction. So here one cosine waveform, sine waveform, another one cosine waveform. Okay, this 2 thing, it is having the different frequency thing. Okay, so here you just consider, so here pi is there. Okay, so I missed to write pi, so pi t. So in this, we have to find out the maximum frequency of this 3 signal. Okay, so first you see here the omega m is equal to 50 pi. Okay, in the second component, omega m is equal to 300 pi. In the third one, omega m3 is equal to 100 pi. So in this 3 thing, which one is highest? 300 pi is highest. Okay, so the highest frequency is omega m is equal to 300 pi. So omega m, it means 2 pi f equal to 300 pi. So pi cancel. If you are calculating the maximum frequency, it is a 150 hertz. Okay, so therefore the Nyquist frequency is Nyquist rate or Nyquist frequency, which is equal to twice the FM. So 300 hertz. So this is the answer. 300 hertz is the answer. Okay. So here it's a multiple choice question only. So that's why this detailed thing no needed. So in this, the given 3 frequency component, which one is highest, you just check. Then you find out only that frequency, and twice that frequency, it is called as the Nyquist frequency. Okay. Then the next problem, the analog signal m of t is given below 4 cos 100 pi t plus 8 sine 200 pi t cos 300 pi t. The Nyquist sampling rate will be dash. Okay. So here in this 3 things, so similar only. So you just find which one is the highest frequency component. Here 100 pi, 200 pi, 300 pi. So in this 3 signal, which one is the highest frequency component? 300 pi. So the maximum frequency omega m is equal to 300 pi. So FM is equal to 150. Okay, so the Nyquist frequency is nothing but 2 into FM. So 300 hertz. Okay, so therefore the Nyquist sampling rate is nothing but 1 divided by 2 FM. So 1 divided by 300. Okay, so 1 by 300 is the answer. Okay, so this is the answer, 1 by 300. Then the next question, determine the Nyquist rate and the Nyquist interval for the signal x of t equal to sync 2000 pi t. Okay, sync 2000 pi t. So here in this, so the Nyquist, so here the Nyquist, okay, the determine the Nyquist rate and Nyquist interval for sync 2000 pi t. So what is sync signal? So sync already you know, sync is nothing but it's a in first unit we discussed, you know, the shape of the sync signal is like sine waveform, but in the mid the signal is having maximum amplitude. When the time increases, the amplitude decreases. This is the sync signal. Okay, so anyway we have to find out the frequency. So the frequency FM is nothing but it is omega m is equal to 2000 pi. Okay, so from this FM is equal to 2000 pi divided by 2 pi. So pi cancel. This 2 cancel means we will get 1000 hertz. Okay, so the Nyquist rate is nothing but 2 into FM. Okay, so the Nyquist rate is nothing but 2 into FM. So it is 2 into 1000, 2000 hertz. Okay, and the Nyquist interval is equal to 1 divided by the Nyquist rate. So it is called as the 1 by 2000. It is called as 0.5 milliseconds. So 2000, 0.5 millisecond. B is the answer. Okay, B is the answer. So in this, that is the Nyquist interval. Okay, so the question is the Nyquist interval will be, what is the answer? Okay, so the Nyquist interval, this is not a sampling rate, this is the Nyquist interval. So the Nyquist interval is 1 by 300 seconds. Okay, 300 seconds. And the next one, the analog signal x of t equal to cos 20 pi t is sampled with sampling frequency 40 hertz. Uptime the associated discrete time signal. Okay, so here the continuous time signal is given. If you are sampling this signal with the sampling frequency fs equal to 40 hertz means what is the associated discrete time signal? Okay, so in order to convert the continuous time signal x of t into x of n, you just replace the variable t divided by n divided by fs. So where fs is the sampling frequency. So here the sampling frequency is given as 40. Okay, so that's why what is the given signal? X of t equal to cos 20 pi t. So instead of this t, we have to substitute n divided by 40. So cos 20 pi n divided by 40. So cos pi by 2n. So this is the discrete time signal we will get after sampling process. Okay, so after sampling, in order to convert the continuous time signal, that is the other name of continuous signal is called as analog signal. So in order to convert the continuous signals into discrete signal, you just replace in the place of t, you just replace by n by fs, where fs is the sampling frequency. So cos pi by 2n, this is the answer. Okay, so these are all the some of the questions about the sampling process. So in that signal sense and video itself, I solved so many problems. You go and check. Okay, so I will give link for that sampling process and the problem video link in the description box, and iCode also. You go and study that one. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. Thank you.